Hey, Keith Bennett here, author of CovLoupe. CovLoupe is a semantic interface to the test coverage data generated by SimpleCov. It offers structured queries into that data for consumption by developers, tools, and AI assistants. You can use CovLoupe in any of three modes: as an MCP server installed in your AI tool, such as Claude Code or Codex; as a command line application, run individually on the command line or in the script; and as a Ruby gem, using its classes and methods in your own Ruby project. It reads and processes the SimpleCov generated result set file, and then provides semantic access to that data, depending on the mode, in MCP server mode as tools, and CLI mode as subcommands, and as I said, as a gem in its Ruby classes and methods. There are two major uses for CovLoupe. The first is to assist an AI model in the generation of a prioritized task list. CovLoupe simplifies the model's access to the coverage data. Instead of having to parse and understand the JSON itself, it provides meaningful methods. And then the model can map that file and line coverage that CovLoupe provides from the SimpleCov data to higher level logical code-based parts, such as subsystems, components, models, views, controllers, etc. And the model can also judge the criticality and level of effort for improving the coverage of each of those logical parts of the code base. Outputs from the model can be tables of tasks in priority order, prompts to be assigned to other agents to write the tests, or it can write the test itself after making the analysis. Here is a sample prompt that is part of the code base that you can use to ask your AI model, using CovLoupe as an MCP server, to give you a detailed analysis of the state of your code base with respect to test coverage. I think if you paste this into your AI tool and run it, you'll get some useful information out of it. In addition, there are other prompts that I have in the code base that might be helpful to you. They're not related to test coverage, but I found them useful to myself as I was working, and so they're there in case you are interested. The other major use of CovLoupe is to provide a CI gatekeeper, where you can enforce a minimum amount of test coverage. And unlike SimpleCov, which gives you some very elementary tests for the coverage, you can make this as complex as you need it to be. Here is a very simple test, though. We have here a lambda, and this can be any callable. Right here, it's a lambda, but it could be a non-lambda proc. It could be a class with a class method named call. It could be the instance of a class having an instance method named call, or because this is Ruby, it could be any arbitrary object on which you attach a method named call. So we have here a lambda, put it in a file. The callable code that you provide must take a model as a parameter, and that is the coverage model provided by CovLoupe. And then you can query that model object in various ways. So here is a predicate, and a predicate is something that returns true or false. So these are all predicates. So here's a predicate that returns true if and only if every single file has a coverage of at least 10%. And this one is exactly the same, except 100%. So I made these numbers extreme so that the first would pass and the second would fail. Here is how you would call it. You would call CovLoupe with a validate subcommand and provide the file spec. And then CovLoupe would read the file, eval the code string, and call it, passing it the model. And then based on the result, whether it's true or false, exit with the appropriate exit code, exit the CovLoupe process itself. So here's an example where we're passing a B10 and it passes. And so if we inspect the exit code, we will see that it's 0, meaning success. And with 100%, it'll be 1, meaning failure. Now, this is a very naive and simple test. The next step up from this would be to divide your code into 2 parts, critical and non-critical. So here is a method that you could use to do that. And for simplification for this illustration, we will assume that all of the critical code is in the libcritical directory tree, and all of the non-critical code is in every other place in the code base. So using Ruby's wonderful partition method, we can take an array and create from it 2 arrays based on whether or not the value in the code block returns a truthy value. And so here we create those 2 arrays, and then we ask the critical array, hey, are all of your elements 100%? And hey, non-critical array, are all of your elements at least 90%? And this will return a true or a false, and that will be processed accordingly. Now, of course, this can be of any arbitrary degree of complexity. You can do whatever you want here. There is also an option to pass it on the command line instead of in a file. Here are the options. The SimpleCov result set is normally in the coverage subdirectory with a file name of .resultset.json, but you can override that if you like with this option. The code base root is normally the current directory, but you can override that with this. We provide multiple output formats that you can specify with this. And the list subcommand, which prints out a list of the files in order of their coverage percentage. It defaults to descending so that when it finishes scrolling, you'll see the files most in need of help, but you can override that if you like. For the subcommands that take 1 file as an argument, you can specify whether or not you want to see the source code in addition to the statistics. And you can specify whether you want full or uncovered. For the uncovered, if you specify uncovered here, then you can specify a number of context lines around it, defaulting to 2, around each uncovered line. Normally, color is used for output, but you can disable that. Staleness refers to if the code base has changed since the result set was generated. Files can be added, removed, changed, and CovLoupe will determine this state, and you get to decide whether you wanted to continue giving you a warning, but continuing, or raising an error and aborting. So that's what this option is. Default is false, so it will keep on going. You can use tracked globs to constrain the subset of the code base that you wanted to operate on. Of course, we have a help option. The log file defaults to the current directory with the name of cov.log here, but you can override that. The execution mode is very, very important. If you're running this as an MCP server, using this option is absolutely essential. Otherwise, it will not work. And you may not know that it's not working because it may figure out that it can call the command line instead, but then it's loading and processing the result set with every single call, which is kind of a waste. It could slow you down. So when you configure your MCP client, such as Claude Code, you need to make sure that you are providing arguments in addition to the executable name. And the arguments should be -m and then MCP. The error mode determines how much is written to the log file when an error occurs. The output counts refers to line characters that are used to show human display readable tables, human-friendly display tables. Normally, it's very nice lines that are shown continuously, but some terminals or character sets might not support that, so you can force ASCII only if you need to. We have version option, and we have a path for name, which I'll get into a little bit later. Here is a sample output table. If you look at the command, you'll see that I have not specified a subcommand because list is the default subcommand. So you can produce this list. It's in descending order of coverage, shows the number of, for each file, the number of lines that are covered and the number of lines that are eligible for coverage. This number will not include blank lines, comment lines, etc. And then we have a stale column, which shows you if any of the files are stale, and if so, how it determined that. Now, of course, SimpleCov has their own web interface to the coverage data, which is nicer than this and more fully functional. So if you're just inspecting this data, the SimpleCov generated HTML itself might be better, but this can be handy to put in scripts or to just quickly run on the command line if you want. The detailed display subcommand will show you the detail for each line of code, how many times it was covered in the tests. And if you specify the -s option, then you'll also see the source code, as we mentioned before. And so here I'm specifying, I only want to see the uncovered lines, but give me 2 context lines around each of those. And so you can see here we have X's and checks, and the lines that are not eligible for coverage don't have either. Output formats. I specialize in command line applications, and whenever an application emits data, I try to provide as many options for that output format as possible because it's very simple to do and it can be very useful for the user. This is what they look like, the ones that we have available here: plain JSON, pretty JSON, YAML, amazing print, which is the same as awesome print, and the table format. And here are those continuous lines that I was telling you about before. Here is an example of the totals subcommand, and specifying here amazing print as the format. So you see we have some nice colors and indentation telling us about the data. CovLoupe has default values, but you may want to override those default values either globally or locally. If you want to override them globally, you can, in your .zshrc or .bashrc file, etc., export this environment variable with the options that you want. And then you can override them on the command line if you need to. So here's an example of, in a shell, just running the export command here. And then we run this command without specifying the format, and it is output in YAML format. So I mentioned the startup files for global, but for local, you could just have the export in a single shell, and it would just take effect for that shell. I mentioned before the path4 option, the path4 option, and it has 3 possible arguments: repo, docs, and docs local. The repo will return the URL for this project's GitHub location. And the docs will return the URL for the docs server, and docs local will return the file spec of the README in the installed gem, wherever it happens to be. Now, if you combine these with your system's open command, then this is a very convenient way to open one of these resources without needing to remember where it's located. The backticks say to the shell, run this command and substitute in this command the output of standard out for this command. And so it'll, in this case, it'll replace this with this, and then pass that as an argument to open. And open on Mac OS and some Linux environments will look for the default application for that argument type. In this case, it's a web URL, so it'll open a web browser and pass it this. In this case, it's a markdown file, so it'll look to see what is the default application for .md files, and it'll open this file with that application. There's also a $paren notation you can use instead of this, but I find as a practical matter, typing backticks is just a lot faster and easier than the $parens. There's a doc server. Here's the URL for it. I have it pre-opened here. And this is a little bit better than the static markdown that you might find on the project website. It generates some helpful links here and has a search bar as well. And so it can help you get information on specific subjects. So in that sense, it's a lot more useful than just the static markdown. And this is how you might learn more about the code base. But you know what? Maybe you don't even need to do that because you can ask AI to do that for you. Here is a sample prompt where I say, examine the CovLoupe local docs. I'm assuming it's faster and simpler. And tell me how I would write a predicate that verifies the coverage for all lines and all files, that is, in the aggregate, is at least 80%. And this is its response. It gives you the code to do that. And this is a little bit different from the other example, because in the other example, every file had to have that minimum. But in this case, it's just the aggregate number has to meet that minimum. And it very helpfully also offers how to do it in line on the command line. And this can be very handy if your CI environment, for example, it's not so easy to add another file, the Ruby file that this would normally live in. You can pass it a string on the command line with the -i option, and it will look for it there instead. And as a suggestion to you, if your criteria, if your predicate here becomes more complex, I suggest creating a file as the canonical source and just asking AI to create the string for the command line, because it may be quite complex and is something that an AI model is much better at doing than a human is. And it just might save you a lot of time. So that's it. Thank you so much for watching. I really hope CovLoupe is useful for you. I have some individual links here. Feel free to get in touch with me. Let me know how it's useful, how it's not. You can post issues, of course, on the project website. And I hope you enjoy it.